Okay, so our first example from 30-1, what this is going to look like. Using the rational formula y equals a over x minus h plus k as a basic guideline, sketch the graph of function y equals 3 over x plus 1 plus 5 using transformations, and identify the most characteristic and most important characteristics of the graph. So how I would start this out with is I would actually graph my y equals 1 over x. Meaning, so I've got 1, 1, and these are just substituting points in. So like when x is 2, we get 0.5. When x is 4, you get 0.25. And going the other way, so when x is 0.5, you get 2. And when x is 0.25, you get 4. So now that I've got that, I'm not even going to draw actually. I'm not going to connect these because I want to transform each of these points. We don't want to forget about the negative side of this as well. It looks exactly the same though. So you're looking at -2 and -4. And then when you have x is -0.5, you're going to get -2. And then when x is -0.25, you'll get -4. So we have some points that we can play with. And I'm just going to label that is x equals 1 over x. Now let's take the transformations that have actually occurred. So we've got a 5 here, plus 5. So that means I'm going to go 5 up. And then we also have a 3. So it's vertically stretched by 3. Or by a factor of 3. I'll just write 3. And then in the denominator, I've got a plus 1. So that's actually going to be a minus 1. So it's going to be 1 left. So we just have to make sure that we do this vertical stretch before we go up 5. So we'll look at each of these points. I'm actually going to do my asymptote first. It doesn't care about the vertical stretch. And it does say go 1 to the left. So I'll move that right here. So that's going to be my vertical asymptote. And then we can start doing our other points. And we can kind of tell if they're right just based on that asymptote, where it's kind of sitting. So I've got a vertical stretch of 3. So I'll take this point times 3 is 3. And then 5 more up. So now I'm all the way up at 8. And at the same time, I can actually draw this asymptote that was at 0. So it was a vertical stretch of 3. Doesn't do anything, but then we move it 5 up. So we should see that it should approach this line as we go. And I'll put that that's at y equals 5. And this is at x equals -1. And I'll do it to a couple more points. Maybe let's look at this one right here. So it was at -0.25. So it times it by 3, 0.75, go up 5. So then 5.75 needs to be moved 1 to the left though. Okay, so now we can kind of see this graph is going to look something like this and continue on, never actually hitting the asymptote. And then we'll take this one that was at 4, which it might get too big. Yeah, it gets all the way to 12. So I guess we'll take the next one down, which is 2 times 3 is 6. And then we'll move 5 up as well. So just barely on there. And it is going to move 1 to the left though as well. So we kind of get a good idea what this graph would look like. Now for our negative portion of our graph then, same thing. I'll start at the -1 comma -1. So times -3, so we get to -3, and then 5 up. So we're all the way at 2, but then move 1 left. And we'll pick another point. Let's do this one here again, the 0.25. So we get -0.75, and then move up 5. So 1, 2, 3, 4, 5. So we're seeing the same kind of thing. It's going to approach the asymptote. And then we'll pick this -2. So times 3 is -6. Times up 5 is -1. Move over left 1. And we're just looking for the general trend. It might be good to actually have our asymptote here as well, or sorry, our x-intercept here. So to find our x-intercept, we're just going to let y equals 0. So then we get 3 over x plus 1 plus 5. So I'm going to minus 5 off both sides. Then I'm going to multiply both sides by x plus 1. So I get -5 x plus 1 equals 3. Divide both sides by -5. And so you're left with x plus 1 equals 3 over -5. and then we're going to subtract 1 more, so then you're going to get negative 8 over 5, which is approximately negative 1.6. So therefore our point is at negative 1.6 comma 0. And hopefully that kind of makes sense where it is. Yep, it looks pretty accurate, our graph. And there we go. Now we do want to identify some important characteristics, and those are going to be our x-intercept and our asymptotes.